The famed Fermi paradox has bewitched astronomers for more than half a century. To put it concisely, if the cosmos is nearly 14 billion years old, then where are all the interstellar societies? Why haven't they popped over to say hello? Myriad solutions to this conundrum have been proposed, but perhaps none more chilling than the dark forest theory. As the supposition holds, the reason we can't see these alien civilizations is because they're all in hiding, unlike humanity, whose radio transmissions have long echoed throughout our local galactic neighborhood. These societies have all concluded that it's simply too dangerous to broadcast their location to potentially hostile neighbors. It's a sobering thought, and one that's gaining attention now that it's being depicted in Three Body Problem, a Netflix adaptation of author Ho Cixin Liar's literary trilogy. But is it a plausible solution to the Fermi paradox? Of all of the posited answers, experts say the dark forest hypothesis seems less likely to be correct. It's possible that several extraterrestrial intelligences, or ETS, would conceal themselves, but it's improbable that all of them will come to the same fear-based conclusion and hide away. We don't even see that same behavior on cultures here on Earth, says Muya Maksir, an astrophysicist, author, and folklorist. Some ETS might have members that all act in perfect unison, but others will have divergent, independently behaving groups, some who trend more toward aggression or pacifism, curiosity, or reclusiveness. If one of them waves hello, then that dark forest will get a brightly lit campfire for us to see. But technically, anything is possible, considering we don't have any evidence for ETS to begin with. Perhaps everyone really is hiding. Maybe there truly is a threat lurking out there, somewhere in the dark, and maybe humanity just hasn't realized it yet. The case for the dark forest theory, the Fermi paradox, was casually raised by physicist Enrico Fermi during a lunchtime chatway back in 1950. It has many nuances, but at its heart is this central premise. Our solar system is just 4.6 billion years old, whereas the universe is 13.8 billion years old. That is plenty of time for life on other planets to develop into technologically advanced societies, those that could set forth across the sea of stars and create outposts or new societies on countless worlds. But we have yet to find any sign of these societies. So, where is everybody? There are so many possible overlapping solutions to the Fermi paradox. Says Makia, is space simply too vast for alien societies to have reached Earth yet? Do all of them destroy themselves before becoming interstellar? Are we the only technologically advanced society in our corner of the cosmos? Is the evolution of life vanishingly rare? All the Fermi paradox tells you is that civilizations are rare. It doesn't tell you why they're rare, says Ian Crawford, a planetary scientist and astrobiologist at Birkbeck, University of London. One of the solutions is, yeah, they're all out there, but they're all hiding. If they give themselves away, someone will come and destroy them. The idea that these spacefaring aliens are simply reluctant to reveal themselves has featured in sci-fi storytelling for many decades. Liu, in his 2008 book, gave the hypothesis a catchy name. He describes the universe as a dark forest, wherein each alien society is like a fearful, armed hunter gingerly moving forth. If that hunter finds other life, another hunter, an angel or a demon, a delicate infant or a tottering old man, a fairy or a demigod, there's only one thing he can do: open fire and eliminate them. In this forest, hell is other people. Being fearful has its evolutionary benefits. We might flinch at a strange noise in the night, and although most of the time it's harmless, our caution might save our lives. The one time it's coming from a genuine threat, it can't be denied that there is some survival value in being aggressive. Seth Shostak, a senior astronomer at the Search for Extraterrestrial Intelligence Institute in California, preemptively take out the competition, and you might sleep more securely while getting extra resources. The history of humanity and its present is littered with grim examples of this. The case against the dark forest theory, thankfully. The dark forest has a plethora of issues that are difficult to resolve, the most obvious being that it's extremely defeating as we've begun to grasp the hypothetical threat. It's not like we're about to go completely silent either. We've never given the slightest thought to turning off all the radars because it might be dangerous, says Shostak. It's just not gonna happen. Even if an ATI tried to conceal itself, it might not be sophisticated enough to work. Some alien societies might have found a way to stamp out all the noise, but others might be accidentally still giving the game away without realizing. The way cavemen might hide is quite different from the way Klingons might hide, says Shostak. The forest analogy also falls apart when you consider the true nature of the universe, or simply our own ginormous galaxy. The woods can seem huge and endless in the dark, but that's peanuts compared to space. There might be hostile aliens out there, says Shostak, but the distances between them are likely to be unfathomably vast. So much so that the idea they would feel the need to preemptively attack one another seems odd. Even if they feared each other, the expanse between them means that they wouldn't likely need to compete for resources. Each would have near limitless worlds, asteroids, and even stars to explore. The fact that Earth is, by universal standards, a young, noisy, and vulnerable technological society, also by default implies that if there are Edis out there, then they cannot all be instinctively aggressive. If there are so many civilizations, and some of them could destroy us, then we have to explain how that has happened, says Karim Chopra, a researcher at the Institute for Futures in Stanford. Maybe there's a galactic empire that keeps the hostilities down, or maybe it's really difficult to attack each other over interstellar distances, or, as Jebbarara has suggested in a recent paper, that is, have reached the same logical conclusion, that they still exist because other advanced alien societies have chosen not to smite them. We have no reason to attack them in a preemptive strike, says Jebbarara. If they're smart, maybe they're thinking the same thing about us, that all ETs would share the very human instinct of assuming the worst about an unknown entity is also a massive presumption. For me, dark forest is one of the less compelling explanations for the Fermi paradox, because it relies on a few anthropocentric assumptions that I don't think are fair, says Maclear. Fear is a powerful thing, but so is curiosity. The nightmare scenario, that doesn't necessarily mean that the dark forest hypothesis is a non-starter. The problem is that addressing the holes in the theory requires amping up the terror factor. The nightmare scenario is that, suppose those that are hiding are right, says Crawford. Suppose that, sometime in the history of the galaxy, a technological civilization decided that whenever planets with life or technology were found, they were going to destroy it. In other words, if extermination for extermination's sake was the goal, then the dark forest seems more plausible. If something like that has been going on in the history of the galaxy, then yes, it would explain the Fermi paradox, Crawford says. So sure, maybe a corner of the cosmos is quiet, because life getting started in the first place is an extreme rarity. Perhaps it's lonely out here because alien societies have a bad habit of annihilating themselves once they discover something like an atomic weapon, or just might be it. We don't see them because they're not there, says Crawford, because a slaughtering entity is going from star to star, extinguishing any sign of life. That's the really scary thing. Difficult to conceal a technologically advanced world. Long before actively searching for ETIS became a global scientific practice, radio signals from Earth's quotidian intraspecies